Hello everyone, myself Jyotirmoy Kawati, Technical Officer from the Department of Mechanical Engineering, IIT Guwahati. So welcome to IC Engine Laboratory of the Department of Mechanical Engineering. So here in this video we are going to perform an experiment related to a compression ignition engine. We are going to study the various performance parameters of the engine. In this video I along with two other technical staff, Mr. Shandan Manikka and Mr. Jaykrishna Soikia, will help me continue this video and to perform the experiment of this compression ignition engine related to IC engine.
So this is our single cylinder water cooled diesel engine setup. In this setup we will do an experiment to know the performance of the engine in various load conditions. So this is engine part. This part is called cylinder. This is cylinder head. This is flywheel. This is injector to inject the fuel. This is exhaust line, exhaust gas. Then this is inlet, air inlet. Okay. Then this is the dynamometer, eddy current dynamometer to apply the load to the engine. So in this experiment, first we have to observe some data. So you see this observation table, we have to make this observation table, load, speed, air, this is the observation table. The first one is load. We have to apply the load to the engine. So this one is rotating knob. By rotating this knob, we apply the load to the engine and this load will be displayed here. Okay. Then second observation is speed. In this load condition, what is the RPM of the engine? To measure the RPM, this is RPM meter. Here RPM will be shown. Then air. How much air served by the engine in that load condition? To measure the airflow rate, we have the manometer. In this manometer, we measure value of H. Then we can calculate the airflow in kg per hour. Then third observation is fuel consumption. How much fuel consumed in that load condition? To measure the fuel consumption, this is fuel measuring tube. By using stopwatch, we measure the time, how much time required to consume some amount of fuel, suppose 10 ml, 20 ml like this. Okay. Then water flow rate. Water is going to the engine to cool the engine. To know the water flow rate, this is the rotometer for engine. This value will be constant 300 liter per hour in this experiment. And water is going to the calorimeter also. So calorimeter water flow rate, this is the rotometer. This will be 80 liter per hour for this experiment. Okay. Then we have to know the T1 to T6, T1, T2, T3, T4, T5, T6. These are the temperature. So to know the temperature, this is the knob. Here 1, 2, 3, 4, 5, 6. This is T1, T2, T3, T4. We select T1, T2, 3, 4. Then we have to note down T1 to T6. So we describe what are the T1 to T6. So T1 is the temperature. This is jacket water inlet temperature. To measure the T1, we have the temperature sensor. This one is temperature sensor. Through this line, water is going to the engine to cool the engine. To know the engine water inlet temperature, this is the sensor. Through this sensor, we measure T1 and that will be displayed there. Then T3 is calorimeter water inlet temperature. The same water is going to the calorimeter also. This is calorimeter. Calorimeter is a heat exchanger. So for T1 and T3, this is the sensor. Okay. Then T2 is jacket water outlet temperature. After cooling the engine, here sensor is fitted. From this sensor, we know the jacket water outlet temperature. Then T4, calorimeter water outlet temperature. After exchanging the heat, here sensor is fitted. This is T4. Then this is T5, exhaust gas temperature before calorimeter, and this one is T6 exhaust gas temperature after calorimeter. Okay, so these are the T1 to T6. So every load condition we have to take this data. First one is load, speed, air, fuel consumption, water flow rate, then T1 to T6. So we have to take data for the 3-4 load condition. Then from this load condition, ultimately we have to find out this result: brake power, fuel consumption, air flow rate, air fuel ratio, heat equivalent to work, heat cooling to water, heat by exhaust gas. These are the performance we have to measure. For that purpose, we have some formula. You can use your textbook also, and here also some formula is given. By applying this formula, we can find out this result. And after that, we have to do some performance characteristics curve for brake power variation, brake specific fuel consumption, brake thermal efficiency. Okay. Now we start the engine. After starting the engine, we apply load and various load condition. We measure the, note down the data. Now I am adjusting the water flow rate for engine and calorimeter. For engine it is 300 liter per hour, and for calorimeter 80 liter per hour. Now I am applying the load. You see the figure: 2.7, 2.8, 2.9, 3, increasing the load. So I have applied 4.2 kg load. The inbuilt tachometer of this engine setup is not working, so we measure the engine speed through this tachometer. Note down the figure. For this load condition, you note down the data for T1 to T6. This is T1, 26 degrees centigrade. This is T2, 33 degrees centigrade. T1 and T3 are same. This is T4, 33 degrees centigrade. T5, 222 degrees centigrade. Then T6, 160 degrees centigrade. Then you take the data from YouTube manometer reading, see the maximum difference and note down the value. Then we have to check fuel consumption, how much time required for 10 ml consumption. Open the fuel valve. Now fuel is going from this fuel measuring tube to the engine. Take one reference point and start your stopwatch. Fuel is going on. Start the stopwatch. Up to this point it is 10 ml. Now stop the stopwatch and note down the value. Close the valve. Check the rotometer reading. Then go for second load. Now I am applying second load. Seven kg. Now measuring the engine speed through this tachometer. Note down the value. Note down the reading for T1 to T6. This is T1, 26 degrees centigrade. T3 also 26 degrees centigrade. This is T2. This is T4. T5. Then T6. Now see the manometer reading, maximum difference. Then go for fuel measuring tube. Fuel is going on. Start the stopwatch. Stop the stopwatch and note down the value. Close the valve. Then see the water flow rate. That's the way we have to take observation for 3-4 load condition. Then from this observation we have to calculate the result. So this is the manual. You go through this manual. All the important data are available in this manual, and observation readings are also available in the observation table. You see all details and find out the result using this formula, and ultimately you have to do the characteristics curve analysis. Thank you.